We're talking about geometric transformations that preserve congruent figures. In the last video, we talked about translations. In this video, we're going to talk about reflections. So let's take a look at what that looks like. So I'm back on GeoGebra, and once again, I will create a triangle. And remember, when we translated, we specified a vector, which is a direction of how much we want to move right and left, and how much we want to move up or down. What do we do when we want to reflect something? What do we specify? Well, we want to have a line when we do a reflection. So sometimes it's going to be a horizontal line or a vertical line, especially when we're doing work with the coordinate plane, but it could be any old line at all. And so when we do a reflection about a line, we reflect this triangle across this line, and it's kind of like if we had this on a piece of tracing paper and just flip the paper over. So we've got the triangle reflected across this line. One thing I really like to point out to students as they look at this is to notice the order of the order of the points as we go clockwise around a triangle. So going clockwise around the original triangle, we have A, B, C. But if we do the same thing with the reflected triangle, it's A prime to C prime to B prime. So that's a really crucial way. If you look at two figures and you say to yourself, I wonder if that's a reflection or not, you can see if the order of the letters is reversed. And if the order of the corresponding vertices are reversed, then you know that a reflection was involved in it. So this is the basic idea about reflection. We'll have more to say after we do some work in constructions, but there's one other thing I wanted to show to you, and that's if we reflect, if the line we do the reflection across is part of the triangle itself, which is something that we do quite often, then it's going to look like this. So A got mapped to A prime on the other side of the line, but B got mapped to B prime, which is the same point. C got mapped to C prime, which is on the same point. In fact, every point on this line got mapped to the same point. That's an important concept in geometry, and we are going to call those fixed points. So we're going to recognize fixed points when we're doing reflections because they are points that are exactly on the line that we're reflecting across. If the line that we're reflecting across is part of the figure, then the points that are on that line are going to be fixed by the reflection, which means that if I flip the paper over, those points are going to be on the same place they were before. That's going to be an important point for us going forward.